Hello, year 5. I hope that all of you are healthy and safe. In our today's session, we will talk about shadow. The study note number 2 is covering the learner's book from page 96 to 114. However, today we are going to cover till page 5 only in your study note. Let's start. Please concentrate, and I hope that you enjoy the session. What is a shadow? What's meant by a shadow? A shadow is a darkened area which is very dark. Darkened area which is formed as a result of falling of light on an opaque object. So, shadow is a darkened area which is formed as a result of two important factors, which are presence of light or falling of light on an opaque object. So I must have light and I must have an opaque object so I could have a shadow. Shadow is a phenomenon. Shadow is a phenomenon, happens because light travels in a straight line. Do you remember this picture we used last session to clarify that light rays are traveling in straight lines? That's why I told you that this property of light is very important, because shadow will never ever happen if light didn't travel in a straight line. So shadow is a phenomenon happens because light travels in a straight line. Since light travels in a straight line, the shape of a shadow is similar to the object that casts the shadow. One more time. Since light travels in straight lines, the shape of the shadow will be always similar to the object that casts the shadow. Note the flower and its shadow. The shadow is similar to the flower. However, importantly, note that shadow doesn't contain any details. It's only a darkened area. Think about your shadow. If you were on a sunny day and going out, and you're going to find your shadow beneath your legs. Have a look on your shadow. You're going to find it's a darkened area. You can't see your nose, your eyes, your ears. You are going to see only outlines. There is no details formed inside a shadow. That's why once we started to define shadow, we said it's a darkened area. Darkened area means there will be no details at all. How shadow forms? Please concentrate in this picture and try to understand what I'm saying. However, I'm going to say it one more time, written in front of you. But please try to imagine the mechanism while I'm explaining using the diagram. The torch gives off a beam of light. Each ray in the beam of light travels in a straight line in a certain direction. As shown in the diagram, the straight lines coming from the torch represent rays of light. The arrows show the direction of traveling light. And we said before that the presence of arrow is very, very important. As shadow forms when the tennis ball blocks the light from the torch. Why do you think the tennis ball blocks the light? We said that from the important factors should be present to have a shadow, an opaque object. And since he said that shadow forms when the tennis ball blocks the light, so tennis ball is what? Perfect. It's an opaque object. The shadow forms on the opposite side on the tennis ball to the torch, and the shadow is cast on the wall. One more time. The torch gives off a beam of light. And as the scientists say, that a beam of light is made up of lots of rays of light. Each ray travels in a straight line in a certain direction. In the previous diagram, the straight lines were coming from the torch. They represent rays of light, and the arrows show the direction of traveling light. A shadow forms when the tennis ball blocks the light from the torch. The shadow forms on the opposite side on the tennis ball to the torch. The shadow is cast on the wall. Light and materials. Some materials cast better shadow than others. Of course, not all materials are going to have the same shadow. Some materials would cast the shadow better than others. So the materials can be classified or grouped or sorted according to their ability to pass light through them. One more time, the materials can be classified, grouped, or sorted according to their ability to pass light through them. They are going to be classified into transparent materials, translucent materials, which are also known as semi-transparent, and opaque materials. Let's note together each type of material, what are their main properties. Transparent materials. They are materials that allow most of light to pass through. We didn't say all of light, but we may say most of light. So transparent materials allow most of light to pass through. So the objects behind the material can be seen clearly, in full details. If you try to look for an object behind the transparent material, you are going to see it very clearly with its full details. We have many examples like clear glass, what we use in the windows. That's why windows are transparent and we can see whoever passing by it. Clear water, air, of course air is transparent. Transparent plastic, like those sheets of plastic. It's transparent and allow most of light to pass through. So transparent materials are materials that allow most of light to pass through, and that's why objects behind the material can be seen clearly in their full details. Translucent materials. Translucent materials just allow some light, not most of light. Translucent materials allow some light to pass through. So objects behind the material can be seen less clearly. You can see the objects, but you will not see it in full details. You will not see it very clear. You are going to see them less clearly. Examples are like tissue paper. Have a look to the picture. You can see the hand through this tissue paper, but it's less clearly, not in full details. Frosted glass. Do you know what the frosted glass? The frosted glass is the type of glass we use in the bathrooms. Go and have a look into your bathroom. Look at the window. You're going to find out that the window is covered with frosted glass because it's a translucent. No one outside can see you clearly. That's why frosted glasses are usually used in the bathrooms. A sheet of a paper also is a translucent material. So one more time, translucent materials are materials that allow some light to pass through. And that's why objects behind the material can be seen less clearly with some details, not in a fully detail. Like the tissue paper shown in the picture, there is a hand behind the tissue paper, but you can see it less clearly. Same as the frosted glass, you can see what's behind it, but less clearly too. What about opaque materials? materials don't allow light to pass through them. Never ever. The light will not pass through them by any way. They are going to block the light. So the object behind the opaque material can't be seen at all. Opaque material don't allow light to pass through. They never ever allow the light to pass. So if you try to look through an opaque material, you cannot see any object behind the material, because objects behind the material can't be seen at all. For example, rocks. Rocks are opaque material. If you held a rock and try to see what's behind it, you can't see it at all. It's an opaque material. Aluminium foil. This is the aluminium foil. What do you think? If you held up this aluminium foil and try to see what's behind it, can you see it? Of course, no. It's an opaque material and it will not allow light to pass through. And as we said before, we cannot see an object without light bouncing off it. So if light is not allowed to pass, so light will not reflect it in the object behind the material. That's why it can't be seen at all. Your books. Try to hold your book. What do you think? You can't see what's behind it. Also, carton or cardboard. They are an opaque material. Shadow shape. The shape of a shadow doesn't only depend on the shape of object that cast it. We said before that the shape of shadow is similar to the shape of the object that cast it. However, its shape or its size will not only depend on the shape of the object. The shape of a shadow also depends on the position or the place of the light source. The position or the place of the light source. Where you place the light source, the shape of shadow will depend on it. And the shape of the surface in which the shadow is cast. One more time. The shape of a shadow depends on the position or place of the light source and the shape of the surface on which a shadow is cast. As the surface could be smooth or uneven, not all surfaces are alike or all are the same. The shadow area or the size of the shadow is changing by changing the position of the object with respect to the light source. So I'm going to fix the light source and start to change the position of the object. If I did this so, I would find that the shadow area is going to be changed. So the shadow area is changed by changing the position of the object with respect to the light source. With respect to the light source means that I'm going to fix the place of the light source and I'm going to change the position of my object. By this way, I'm going to change the size of the shadow area. You're going to find out that the nearer or the closer the object to the light source, the bigger or the larger the shadow. So as you bring the object nearer or closer to the light source, you're going to find that this object will cast a bigger shadow. And on the contrary, the farther the object away the light source, the smaller the shadow. If you took the object far away from the light source, the object will cast a smaller shadow. Let's see the example to understand it very well. These pictures show different sizes of shadow. First picture shows a large shadow because the toy is close or near to the light. We have a large shadow because the toy is close to the light. And as we said right now, The closer the object to the light source, the bigger or the larger the shadow. So here we have a large shadow because the toy is close to the light. What about the second picture? What do you think? We didn't change the position of the light source. Please take care. We keep the light source fixed in its position, but we are going to change the position of the toy or of the object. So in the second picture, we will find out that the shadow starts to become smaller as the toy moves away from the light. In the second picture, we have a small shadow because the toy is far away from the light. What about the third picture? In the third picture, a very, very small or a tiny shadow is cast because the toy becomes very, very far away from the light. We have a tiny shadow because the toy is very far away from the light. And this clarifies that the farther the object away the light source, the smaller the shadow. So one more time. The first picture shows a large shadow. And this is because the toy is close to the light source. Please take care that in those three pictures, we didn't change the position of the light source. We kept the light source in its same position. We just changed the position of the toy. So when we place the toy close to the light source, we got a large shadow. Because as we go nearer or closer to the light source, the shadow becomes larger. In the second picture, the shadows start to be smaller. We have the small shadow because the toy is far away from the light. And we said, as we took the object far away, or the farther the object away from the light source, the smaller the shadow. In the third picture, there is a tiny shadow because the toy is very, very far away from the light source. And this clarifies that the farther the object away, as we go farther away from the light source, the shadow will be smaller and smaller. By this slide, our today's session has finished. Please write down all your questions in a piece of paper so we can discuss them next Thursday during the online session. Your today's homework will be in your workbook, pages 55, 56, and 58. And in page 60, you have to answer question number 1 only. By the end of the week, a model answer will be sent to you so you can check your answers easily. Thank you so much, my beloved students, for your concentration. See you next session. Goodbye.